Okay, welcome to the next part of the course, which deals with the concept of atomic mass. So we had briefly touched upon this concept previously when we were discussing about the mass number of any atom, right? So the mass number of any element, which was the number of protons plus the number of neutrons, right? And we also briefly discussed the concept of average average atomic mass and the concept of natural abundance, and how to calculate the atomic weight we just have to get the average of all the atoms that are there in nature and just get the average of all those atoms, and that's how we get the atomic mass of any element, right? So in here we formally define what an atomic mass is. So it's the same thing that we discussed earlier. In here, atomic mass is defined as the average mass of one of the atoms of the numerous and countless number of atoms that are there in nature, right? So you might have a whole lot different. So if we take the example of, say, sodium, right? So if you remember, so sodium, the atomic number is 11, the mass number is 23, so therefore the number of protons in here is 11, the number of neutrons is 23 minus 11, which is 12, and the number of electrons, since it's a neutral atom, it is again 11 protons and 11 electrons. Now, we briefly saw that this was given the mass number when expressed in grams gives you the atomic weight. Now this has a very specific connotation, and we will try to understand what that exactly means. But in here, let's try and understand this in a more basic way. Okay, so the atomic mass or weight, and in here we will interchangeably, so people in chemistry interchangeably use the concept of mass and weight. In physics, mass and weight are two different quantities, right? So mass has a unit of kg or grams, weight is basically a force, so it has a unit of newtons. But in here, we'll generally use those two terms interchangeably, and what we mean is mass. Even if I'm telling weight, atomic weight, I'm meaning atomic mass. So the unit is a unit of mass, not the unit of force, which is weight. Okay, so simply speaking, what an atomic weight should be. So what are the things that you have in atom? So atom has a nucleus and it has the electron cloud, right? So what are the things that you have in atom? What is the atom made up of? So the atom is made up of the nucleus, and it is made up of electrons, right? The nucleus in turn is made up of protons plus neutrons, right? So the atomic weight basically should be the mass of all the number of protons plus all the number of neutrons plus all the number of electrons, right? So this is really simple, right? If there is a machine and it has three parts, so in order to get the weight or mass of the machine, what do? If you just measure, so it will be equal to the mass of the individual components, right? And here, the atoms and any atom is made up of nucleus, which is protons and neutrons. Add them up, add the mass of this, and then you will get the atomic weight, right? Pretty simple. Now, please remember on an average, protons and neutrons generally weigh the same, right? But the electrons are very, very light, right? About 2,000 times lighter than protons. It's basically 1836 times lighter than the protons, and the neutrons are about 0.14% more heavier than the protons. And we have discussed this in chapter 2, I guess, of this whole series, right? So if you try and remember these, remember and recapitulate, you can go back and read that chapter. Or in here, just remember that the protons and the neutrons are more or less weigh the same, but the electrons are very light. In this regard, also remember that we discussed that there is a concept of binding energy, right? So when you add these protons and neutrons and all the electrons, generally there is the mass of the nucleus is not exactly equal to the mass of the protons plus the mass of the neutrons that make up the nucleus. It's not exactly the same. There is a certain amount of mass deficit, right? So what happens when you have different kinds of protons moving in space and then you have different kinds of neutrons? So what happens when you form a nucleus, so when you're forming the nucleus, when things are coming close together and forming a nucleus, and as a stable nucleus, what happens? You release a tiny bit of energy, which is called the binding energy of the nucleus. So when you release energy, you are decreasing your own energy, right? So if you had certain amount of energy and then you released it, so you are making the energy that you had a little less, and in that process you're making yourself more stable. So that's what the nucleus does. So when all those different kinds of things came in order to bind them, it released a tiny amount of, it released a huge amount of energy, right? This is actually a lot, it's a large amount of energy known as the binding energy, but the mass associated with that energy, and that, if you remember, the binding energy was calculated by mass times c squared, the famous Einstein equation, right? Energy is equal to mass times the c squared. And this mass is basically the change in the mass, right? So there was a tiny amount of energy that was released. So this delta m means there was some final mass of the atom. There was some kind of like there was some kind of initial mass of the nucleus, and there was some kind of final mass. These two are not same. The final mass is a slightly lower value. So the difference, if you take that difference and then multiply by this squared of the speed of light, which is 3 into 10 to the power 8 meter per second, if you multiply with that, this energy is called the binding energy, right? So this is the binding energy. And because of this, your nucleus is stable, and that's why you cannot normally change the number of protons and neutrons in the nucleus. So those kinds of changes in the nucleus involve a big amount of energy investment. So in general chemistry, your nucleus is very stable. Why is it stable? Because of this binding energy. This binding energy was released, and this release of binding energy made the nucleus stable. However, the mass deficit that happened when you release this binding energy is not a lot, right? So if you actually go on and calculate the mass of the protons and the mass of neutrons and the mass of electrons and add them up, which is the atomic weight, it's not very different from the actual mass. Okay? The mass is really small, but the energy is a lot, because you're multiplying it with a big number. Like this is 3 into 10 to the power 8 meter per second squared. It's a big amount of energy, right? But the mass involved is same. So for our purposes, what we'll understand is the mass of the atom is basically the mass of the protons plus the mass of the neutrons plus the mass of the electrons. This delta m that was released is a very small amount and can be neglected. Also, the mass of the electrons, this being 1836 or about 2000 times lighter than the protons, also have very minimal effect, right? So therefore, the majority of the atomic mass is basically coming from the nucleus, which is comprised of the neutrons and the protons. Okay? All right. So this is the general concept. Now we would want to find out what is the atomic mass of any atom, right? Now we discussed this earlier, that how you have chlorine as 35.5, right? So the atomic mass of chlorine is 35.5. Why is this 35.5? Because this was calculated to be an average of the different isotopes of chlorine. So chlorine has 2 isotopes, right? We have discussed this in a previous lecture, right? So if you have forgotten that, go to that, and like we discussed this, how we came up with this idea of 35.5. So this is basically the average, and that is why you start to get like really complicated numbers in here. In here, you don't have like partial or half a proton or half a neutron. You don't. But in here, since this is an average and it's based on the natural abundance, you get fractional numbers and decimal numbers in here. Okay, so please remember this. This is the natural. So this is the average of the natural abundance of all the atoms that are present. Okay, all right. So average mass of the atoms that are present in the nature is basically the atomic mass or the atomic weight. Okay, now, just for example, so this was 23. So what we generally say, and this will be more clear in mole concept, is that the atomic weight, we say the atomic weight of sodium is basically 23 grams or 23 U. Now what is U? U is called the atomic mass unit. Now, why do we need another unit? So for anything like, for any quantity, the measurement should be in the right units for any quantity. Say you're measuring the mass of human beings. So what is the unit? You generally use kilograms or pounds, right? But let's suppose you are trying to measure the weight of a truck. So basically you'll go to tons, right? So you try and measure things in bigger units. Now, let's say you are trying to measure the mass of microbes, say like really small things. So in those kinds of, you won't be using tons as a mass unit, right? So in here too, since atom is a very small particle, it's an extremely small thing, so the mass of the atoms are measured in a new type of unit, and that is called the atomic mass unit. Now there's a relationship between this gram and this U. Now the atomic mass, when we say, people can represent the atomic mass in two ways. Now I can say the atomic mass of sodium is 23 grams, and that will mean that 1 mole of sodium atoms will have a weight of 23 grams. Some people say like this, okay, the atomic mass of sodium is 23 grams. That means 1 mole of sodium atoms has this weight. Now again, the concept of mole will be understood clearly in the mole concept, but for now, please understand that a mole is a number. It's like dozen mean 12, right? So a score means 20. So 1 mole is a pair means 2. So 1 mole is also a kind of a measure of a quantity. So 1 mole is also a set of numbers. So you can have 1 mole of anything, right? You can have a dozen of cupcakes. You can have a score of books, right? So you can have a mole of books. You can have a mole of chalks. You can have a mole of students. You can have a mole of anything. So in here, we are just having a mole of sodium atoms. Now what is this number? If this was dozen, we would have written 12. This is a big number. It's actually a very big number. This means that 6.022 into 10⁻23 atoms, this is called the Avogadro number, atoms of sodium is going to weigh 23 grams. This is the meaning of an atomic weight, okay? So 1 mole or Avogadro number, this is also represented by this number. So Avogadro number. So we'll discuss about these things in mole concepts in more detail, okay? For purposes in here, let's understand that, okay, if you just have 6.022 into 10⁻23 atoms of sodium, how much will that weigh? 23 grams. If this was magnesium, how much will it weigh? 1 mole of atoms of magnesium will weigh 24 grams, because the atomic mass, the mass number of magnesium was 24 for easy purposes. What does this mean? 1 mole of chlorine atoms will give you 35.5 grams. Why 35.5? Again, natural abundances, different kinds of isotopes, right? So that was discussed before. Like why do we have the decimal? But for here, please understand that these many atoms will give you 23 grams. This, if you say 23 grams, this doesn't mean that the atomic weight of one sodium atom is 23 grams. It is not. It is the atomic weight of 1 mole of atoms. Now, how do we calculate the weight of one atom? We'll just use unitary method, right? So, similarly, if you have sodium, let's take the simplest of the cases. Let's take hydrogen. So, 6.022 into 10 to the power 23 atoms of hydrogen. How much will they weigh? Hydrogen is 1, 1, right? Hydrogen is 1, 1. So it will weigh 1 gram, okay? So this will weigh 1 gram. Simple enough. Now we wish to find out what is the weight of one atom, right? So how will we do it? We'll just use unitary method, right? So we'll write 1 atom of hydrogen will weigh how much? 1 gram over this number, right? Simple. Right? Now, if you calculate this, if you just do the math in here, so 1 over, so this things goes, so this 10 to the power 23 goes from the denominator to the numerator. This becomes 10 to the power minus 23, and I've just done this math previously, and this becomes 1.6605 into 10 to the power minus 24. So 1 over 6.022 is 0.16605. So this is 10 to the power minus 23. But we rearrange that in terms of like scientific notation, and we get 1.6605 into 10 to the power minus 23 into 10 to the power minus 24 grams. So this is the mass of one atom of hydrogen, this number, right? Now, this is becoming really interesting. Why? Because now we can calculate, since we can calculate the number, since we have this, we can also get the atomic weight, so the atomic weight, the weight of one atom of sodium, which will just become 23 times this number, right? So this number is becoming special. So what will be the weight of one atom of carbon? It will be 6, so it will be 12 times, so carbon is C612, so it will become 12 times this number, right? 12 times this in grams will be the mass of one carbon atom. So why not take this number, take this big number and associate a different unit to it? So to make things easier, right? Like chemistry is making things easier for you. So this is a big number. Why not take this and assume and just take another, define another number, define another unit in which 1.6605 into 10 to the power minus 24 grams is basically one atomic unit. Now, if we assume this, then we can absolutely say that, okay, if this is 1 unit, that means one atom of hydrogen is weighing 1 atomic mass unit. This is basically 1 AMU, right? Or 1 U, atomic mass unit, AMU or U, right? So this is basically 1 AMU, 1 U, atomic mass unit. So what is the mass of one hydrogen atom? 1 atomic mass unit. What is the mass of one sodium atom? 23 atomic mass unit, right? And what is the mass of 1 mole of sodium atoms? 23 grams. So now things become really easy, right? So now, just by knowing what one atomic mass unit basically is in grams, we can simplify this whole thing. Now we can say, okay, now if someone asks you what is the mass of one magnesium atom, so you automatically know it's 24 because Mg is Mg1224, so it's 24 AMU. And if that person asks you, okay, so what is that thing in grams, you just multiply 24 times this and you get the answer in grams, right? And if that person asks you, okay, what is the mass of 1 mole of magnesium atoms? The answer is 24 grams, right? Then it is simply 24 grams. So 1 mole of sodium atoms was 23 grams. 1 mole of magnesium atom is 24 grams. And what is the mass of 1 sodium atom? 23 AMU. So this is how, like if we just do this, we are simplifying this whole mathematical thing into just, if you just understand this unit, we have simplified a whole lot of chemistry in here, okay?